Hi everyone. I wanted to throw up another area question for you, or another word problem. Sorry, this is an area question. So a farmer has his bovines in a fenced area that is 13 by 20. That's what's here in the red. Maybe green would have made more sense. He wants to move the fence so the bovines have triple the space. So whatever area this is, he wants this new area to be 3 times that. If he adds an equal width strip around the current area, what's the required width? So we've gone here and we looked at it. It's 20 by 13. And we're going to add a strip of X on each side to get a new area. So you'll recall that area is equal to length times width. And we use these principles. We can do all kinds of area formulas, but we're just going to do this one. And if I look at the area right now, the area has to be equal to 20 plus X on one side and 13 plus X on the other side. And the area that we want, so the original area, I'm going to call it old area because that's what we started with. Old area is equal to length times width. So the old area, I'm going to call it OA for short. Old area is equal to 20 times 13. So the old area is 260 square meters. So the new area, and this is where the most common mistakes are, just not reading the question. The new area is 2 times the old area. Sorry, not 2 times. 3 times. I didn't even read it. 3 times the old area. And the new area, therefore, would equal 780 square meters. All right, multiplying those together. So I can do this 2 ways. I can put in the new area. So let's do it first, doing it long, the math way. So the area is equal to 780, and it's going to equal this function 20 plus X and 13 plus X. And I have to simplify that out, so I get 780 still equals, and I'm going to FOIL this at this point. So 20 times 13 is 260. And then I multiply the outside together, the 20 and that, 20 and the X, so 20X plus 13X plus X squared. So we get 780 equals 260 plus 33X plus X squared. And that doesn't really look like anything we can work with. But if I were to take the 780 to the other side, it's going to become negative now. So I'm going to get 0 equals, and I'm going to move stuff around at the same time. X squared plus 33X, and then plus 260 minus 780. 0 equals X squared plus 33X minus 520. Now I've got this quadratic equation, right? I can put it in the quadratic formula. So I'm just going to set that up. So here's my quadratic equation. You know what, negative b plus or minus square root of b squared minus 4ac all over 2a. Remember that the a is the one that's in front here. This is the b, and that is the c. We're going to plug those numbers in. X equals b is the negative of 33 plus or minus square root of 33 squared minus 4 times 1 times negative 520. Extend that line there. All over 2 times 1. Adjustment page here. X equals negative 33 plus or minus 32 squared minus that. I need a bracket. So I've squared the 33. It gives me 1,089. This is 4 times 1 times 520, which is 2,080. Watch the signs. I've got 2 negatives here, so it gives me a positive. So X is equal to negative 33 plus or minus the square root of that number, which is 3169, and the whole thing is divided by 2. And we'll go down a little further. X equals plus or minus, or sorry, minus 33 plus or minus square root of that number, which is 56.29. Now I'm just going to do the 2 versions. I get X equals negative 33 plus 56.29 all over 2. And x equals negative 33 minus 56.29 all over 2. Those two answers are, I'm going to crunch the number, 11.65 and negative 44.65. I should have a positive and a negative answer. I'm going to take these two. So this would be the width of my strip. So my two answers are this, math-wise. These are my two mathematical answers, as I was saying, before the announcement came on. This one doesn't make sense. I can't have a negative strip. So this is my answer. The width would be 11.65 meters. Let's take that number back up and check it. So go back up the top here. If I make this side 11.65 and this number 11.65, when I put them in, so I got 20 plus 11.65 times 13 plus 11.65. And when I work that out, when I multiply 31.65 by 24.65, right here, 31.65 times 24.65, I get an answer of 780.17, which is slightly larger than the 780, but I rounded that up to 0.65. So those are the right answers. That's how you do it the long way. The shorter way is to use Desmos. So just give me a second. I'm going to erase all this. So I need an area equation. Same thing. 20 plus x, 13 plus x. And I need another area equation, which is the one where we figured out on the left, right down here, 780. So what I'm going to do now is I'm going to change these two values to y, because Desmos works in y. And I'm going to go to Desmos. So just a second. So here I am in Desmos. I'm going to type those two equations in. Y equals bracket 20 plus x. That's the first dimension. And the other one is 13 plus x. That's going to be my first one. And that should graph. We can't see it right now. We'll have to move around a little bit. And our other one is y equals 780. So if I zoom out a bit here, you can start to see my graph. And I need to keep going. One more step. You can see here on the graph, the blue line, that's the 780, and the red line is our graph. To do this, the solution using this method, you need to identify these points here. Right, and so they are, I want the two intersection points. I'm not worried about the intersect. I want, find the lowest if you can find it. So those are our points. So I'm going to take these and I'm going to sketch them back on my diagram. So it looks something like this. Maybe not drawn so crooked. I'll just draw straight lines here. I'll just use this tool. There's my axis. This way. And the graph looks something like this. It's long and it comes across here. It comes up. And this point right here from the graph is 0 in the x and 260, which indicates if I have no 0, then it's the area of 260, which is what I started with. This point right over here, which I'm going to check in a second. And then I've got a line that goes across here. And I'm looking for these 2 points. If I go back, they are both have a 780 height, and these are the two values. This one is 11.647 and 780. And this point over here is negative 44.647 and 780. This means that's the point where my x value that I've increased it by is equal to 780. So the area, sorry, not the area, the width is 11.647 or 65, which is what we found doing the long way. But I've done this, and I need to see this. Use Desmos. Desmos is your friend. So use Desmos. There's my graph. I need that point right there, so I'm going to go back to the graph for a second. I'm going to zoom out a little. Nope, zoom out, in, I should say. And I want this point down here at the lowest point, which is negative 6.5 and negative 12.25. Negative 16.5. If you're wondering how I'm going back and forth so quick, I use Alt and the Tab button. You should learn how to use that. Awesome. So Desmos right there. I've got my two equations. She writes two equations down. They go in Desmos. I sketch the graph that I see. The y-intercept tells me the value when I don't have any extension or width. The minimum point tells us essentially nothing. In this case, it does mean stuff in certain cases. And these are my 2 points right here where I would have the area I want. The negative one doesn't work. You can't have a negative strip, but mathematically it works out. So that's how you'd solve it using Desmos. And the other way was the longer way. Hopefully that makes sense. I know it's a little glitchy, a couple interruptions there, but no worries. If you have any questions, let me know. Thanks.